Myself R. Kavita, Assistant Professor, Department of Artificial Intelligence and Data Science, working at KIT Kalainar Karunanidhi Institute of Technology. In this video lecture, we are going to discuss about steps to train GAN. Before going to the steps, let us see what is a GAN. It's a generative adversarial network perform unsupervised tasks in machine learning. It consists of two models, generated and discriminated. GAN is basically an approach to generate modeling that generates a new set of data based on training data that looks like training data. The generated model takes the random input and generates samples resembling the training data such as images, text, or audio. Its goal is to produce samples indistinguishable from real data. The discriminator network, on the other hand, distinguishes between real and generated samples, classifying real data as real and generated data as fake. Both of them work together to learn and train complex data like audio, video, or image files. The discriminator will try not to be fooled by identifying fake data from real data. The generator aim is to fool the discriminator by producing data that are similar to those in the training set. In this example, the GAN trying to identify if the 100 rupees note is fake or real. So first a noise vector or the input vector is fed to the generator network. The generator network creates fake 100 rupees notes. The real image of 100 rupees note stored in the database are passed to the discriminator along with the fake note. The discriminator then identifies the notes as classifying real or fake. In this, the generator loss will occur if the discriminator identifies the fake notes as fake. So the generator loss which penalize the generator for failing. The back propagation method is used to adjust the each weight in the right direction by calculating the weight's impact on the output. It is also used to obtain gradient, and these gradients can help change the generator weights. The discriminator loss, if the discriminator identifies fake image as a real, the discriminator loss will occur. The discriminator loss penalizes the discriminator for misclassifying a real data instant as fake or fake data instant as a real. The discriminator updates its weight through back propagation from discriminator loss through the discriminator network. Steps to train GAN. So in this, we have 6 steps. Let us discuss one by one. The first step is define a problem. The problem statement is key to success of the project. So the first step is to define your problem. GANs work with different set of problem you are aiming. So you need to define what you are creating, like audio, poem, text, image is the type of the problem. Step 2 is select architecture of GAN. Define how your GAN should look like. Should both your generator and discriminator be multi-layer perceptrons or convolutional neural network? This step will depend on what problem you are trying to solve. Step 3. Train discriminator on real data set. Now discriminator is trained on real data set. It's only having a forward path. No back propagation is there in the training of the discriminator in n epochs. And the data you are providing is without noise and only contains real images. And for fake images, discriminator uses instances created by the generator as a negative output. Now what happens at the time of discriminator training? It classifies both real and fake data. The discriminator loss helps improves its performance and penalizes it when it misclassifies real as fake or vice versa. Weights of the discriminator are updated through discriminator loss. Step 4. Train generator. Provide some fake input for the generator, which will use random noise to generate fake output. When you train generator, the discriminator remains idle. When you train the discriminator, the generator stays idle. During generator training, the model takes random noise as input and tries to transform it into meaningful data. Generating meaningful output takes time and runs over many epochs. Steps to train generator are listed below. Get random noise and produce a generator output. On noise sample, predict generated output from discriminator as original or fake. We calculate discriminator loss, perform back propagation through discriminator and generator both to calculate gradients. Use gradients to update generator weights. Train discriminator on fake data. The generator will pass the generator samples to discriminator, which will predict whether the data is fake or real and provides feedback to the generator. Train generator with the output of the discriminator. Again, generator will be trained on the feedback given by discriminator and try to improve performance. This is an iterative process and continues running until the generator is not successful in making the discriminator full. Thank you.